It is way too dim over here. What up, YouTube fam? I'm just kidding. Michael Oberdick just posted a video. I'm just trying to work out a camera angle that's going to work. Yes, this phone, disconnected. I'm trying to work out a camera angle that don't make my arms look huge. So this is where I do all my video editing. This is where I drink my coffee, and I go through all the tickets, and come Monday morning, there's usually, 17 to 20 new tickets, and I sit here and I type until my fingers bleed for about 30 minutes, and that's it. I'm through all the tickets. It is nothing like the misery I would go through if I were to sit here and try to return 17 phone calls. So for those of you that are following our ticket system and reading what's on the screen, thank you. For those of you that are not, I'm really sorry, but you're winding up falling through the cracks, because if it's not coming to me in the form of a ticket in our ticket system, I do my best to respond to emails and stuff like that, but those typical requests are being overlooked because it's just too much stuff. Let's get things moving. Let's get a repair started. I have no idea what I'm going to fix in front of a camera today. Let's head to the bench and see what we can do. Alright, let's get this camera off of battery power. This thing likes to suck up a set of AA's about every 45 minutes. Me like Duracell, feed me Duracell. Alright, I think we're ready. Hey everyone, Jason here. Today I'm going to be working on an iPhone 6 that was sent here because it would not power on. My description is no power, heat. I'm not going to go back and read exactly what the customer said about this one. I'm just going to dig right in and see what we can see. So let's throw that crap out of the way. And let's use our handy dandy little, very little short corded tweezers here that barely make it around my microscope. I will be upgrading and changing this stuff around to suit my needs very soon. So we're going to set our power supply on 3.8 or 9 volts. We're going to get up there good enough to where this phone will power on. Let's do 4 volts. And I am going to hook my leads up to this phone. With no button press, I get 1.4 amps. For some reason, I was thinking this was a phone that drew a load after button press, but apparently we draw 1.5 amps at button press. So we don't know exactly what is wrong with this phone. We don't, I do know that there's a short on there, because without pressing the button, you should get no load. Like, there should be nothing draining the battery whenever the phone's not powered on. Being that this thing is draining the battery, something is using current, which means there is a short somewhere. So let's go ahead and take the board out of this phone. Okay, we have the board out of this phone. The next thing I'm going to do is I'm going to hook some juice to it, and I'm going to feel to see where the heat is. And let's not put 1.5 amps through our transistor. Let's go ahead, let's clamp this thing on. I'm going to hook up a ground probe here, and then I'm going to hook up something where I can poke around with some voltage. Here, I'm going to max my current out to be sure that this thing gets good and hot. And let's go ahead, I'm going to peel our sticker off the back of here. Carefully, because I would like to reuse it. Alright, so from there I'm going to take my black probe and I'm going to clamp it on the ground. And then I'm going to take my red probe and I'm going to poke around with it. For that, I'm going to take you with me under the microscope, and I'm going to apply current right here on VCC main. And I'm going to check and see who gets hot. So you should be able to see my power supply. You can now. And we're going to put in a little current here right at VCC main. I really should check for continuity so that you can see what sort of a load we will like. Yeah, we'll do that. Okay. So we know we're getting 1.5 amps on VCC main at 4 volts. Anybody want to crunch along there at Ohm's law and see what kind of resistance we should have? Well, I'm going to go ahead and give you the multimeter here on the screen, and I'm going to show you resistance to ground on VCC main. So I'm going to put my black probe on ground, and I'm going to put my red probe on VCC main, and we get 1.1 thousand ohms. Okay, so if you take 4 volts and you run that through 1.1 thousand ohms, I'm pretty sure you're not going to get 1.5 amps. You're going to get a whole lot less than that. So this is a short where once power is applied, it's closing the circuit, I believe. I think. So let's go ahead and use some heat to narrow this down. Yes, that is freeze spray up there on my shelf. No, I'm not going to use it today. And also, I had a lot of people say, why you got all that air duster sitting there? Why don't you use the air duster? Turn it upside down. Well, I'll show you why. This is why. This product contains a bittering agent to help discourage inhalant abuse. See, they put this crap in here to make sure I'm not getting high off of it. But what happens when that stuff comes out of the can and it gets on your stuff, it gets on your bench, it gets on your hands, it gets on anything, and it'll be like the next day and you'll be eating a sandwich and you can't smell it, but you can taste it. This stuff, nasty. The bittering agent in this is disgusting. I don't know when I found out about it, but ever since I got it on my hands for the first time and had trouble getting rid of it, I no longer turn this shit upside down and spray ice out of it if I ever plan on touching whatever it was that I sprayed it on with my hands again. Now, I might just be completely nuts, but this is nasty. So yeah, I do have freeze spray, but I'm not going to use it. I'm going to use my hands and my sensory and my organs. I'm going to use my organ to find this. So let's go ahead and put 4 volts in here at VCC main. Let's let this thing heat up 1.8 amps. I'm trying to find out if the heat's at the top or bottom, folks. I just want something to go by. I'm going to say lots of heat up top. Lots of heat up top. Lots of heat up top. Let's remove the CPU shield. I'd really like to do that on camera, but I'm worried that piece of garbage is going to lock up my machine again. So, warm up the hot air. I'm not going to remove the shield on camera today, guys. Not until I change my arrangement, which that's gonna happen soon. Because I would like to record more video, and this kind of thing really slows me down. Because, I mean, seriously, some days I'm consumed by these little blue baskets. Alright, we're at 390C. The shield ought to let the board fall out from under at any moment. There we go. And we're going to let the board cool off. Okay, let's get this repair moving so I can move on. I still have not looked at this board under the microscope, so let me take you with me under the microscope. And let's see if we can see anything with our eyes. We know that the heat was top-sided here. And it just... this thing has the look of something that's been really hot. It's got a lot of flux. Maybe this could be for me heating it up with my hot air to take off the shield. Some days I think I should have been born with blonde hair. I can tell you that our backlight diode does look a little rusty. And melted too. I'm gonna say, look at that backlight diode. That backlight diode looks like a pile of garbage. On a day when I am out of backlight coils. Damn it. I actually harvested one of those yesterday. Those really suck to deal with. I'll have them here in a day or two. I ordered them from Soldering Supply.com. Let's go ahead and use power on this thing and make sure we are after a faulty backlight circuit. I'm pretty sure we are. And any of you that is repairing backlight on iPhone 6, you do not get in and replace the diode and the driver and whatever one of these caps is shorted without replacing the coil, or that son of a bitch will come back to you. So we're going to take our probe here, and I'm going to put power in right smack dab on VCC main. But before I do that, I'm going to put a little drop of alcohol on our backlight area for a dramatic effect. There we go. And then I'm going to hook power up to VCC main. Right. Yeah. Oh yeah, look at that sucker boil it away. I'm out of backlight coils. This thing needs a full-blown backlight rebuild to solve it. And I don't have a coil. And I'm not going to scrounge one today either. I scrounged one yesterday because I had to, but harvesting the iPhone 6 backlight coil really sucks. It's just, that's one of the things that you wind up using new. So let's see what's up next. This one is waiting for parts. What are we going to record today? The viewers all want a video. We have here an iPhone 6 Plus. I'm revealing the box because the customer who sent this here will most likely recognize their device right off the bat, which I'm not entirely against that. It doesn't always cause issues, but sometimes it does. All right, we'll kick this aside. This phone is an iPhone 6 Plus. It was sent here for no image or no backlight. We really don't know which of the two it is. So let's go ahead and pop the hood on this one. Once again, since I'm operating without that camera, I might cut out the teardowns. I know a lot of people appreciate the teardowns, but there's also a lot of people that wish I would just get to it, man. It's like, seriously, skip to the punch. We actually received a phone from Ireland yesterday. Got phones here on the way from India and all over the world. This is all just really blown up, man. So the ticket system is necessary. If you want to get your stuff worked on, ticket system. If you want to get answers to questions you have about a device that's already here, ticket system. Just because you're submitting a new ticket doesn't mean you're starting a new repair. That is really the best way to open up a line of communication so that we don't lose track of you and lose track of who you are. So let's go ahead and get the screen detached from this iPhone 6 Plus. Being sure not to pound the long screw into every single hole whenever it's reassembled here in a little while. Alright, and let's disconnect the battery from this phone. And I'm going to switch leads. Let's use the other leads. You're getting replaced soon. You remember that. You behave. Your time here is limited. You die on me today, I'm getting in the car, and I'm driving an hour, and I'm going to buy a better power supply. Alright, we're set on 4 volts, and I have the current set on max, which I'm going to try to get this other camera working. Okay, I have rebooted all things USB. And let's see what this camera gives us. Or this phone this phone gives us. Alright, so we get 80 milliamps, 100 milliamps. Come on now, you're not booting yet. 200 milliamps. Alright, this phone is booting. I'm going to say it is booting without image. Okay? Yes, I'm going to say that this is no image, but I'm not 100% sure. So let's disconnect the supply. Let's remove their screen. And then also remove this little sticker. Okay. So far so good on nothing locking up. Alright, let's go for a microscope evaluation. We got some really What in God's name? Seriously? Yeah, it's definitely no image, but I mean, seriously? Where this? Is this international? 1, 2, 3, 4. No, 1, 2, 3. This looks like United States. All right, so I'm looking at some solder paste. It looks like, did somebody try to take the screw hole off of it? I'm not sure what I'm up against here. All right, so at this point, normally what I would do is go ahead and pin out and check and see if any of the chestnut lines are shorted to ground, check and see if backlight signal is there. But whenever I see some stuff like this, I have to go ahead and take this apart because there are solder beads and solder blobs coming out from under the shield, and that's not good. That's not good at all. And now I have to go back and read the ticket. I have solder oozing out from under the shield. So let's go ahead and pull up my beloved software. Yeah, when you're submitting your tickets, it's best to be as descriptive as possible. And like I said, if you are a repair shop and you're sending tons of devices and you want to track things with your ticket ID, if you include your ticket number anywhere in your request or our ticket, like when you submit your request, up at the top where you put in your device name or whatever, you can include the ticket number there, and I'll make sure and put that in with the job name, and that's going to allow you to be able to search for things in our system. Also, some of you that are accumulating tons of jobs, I've got a couple of you that feel like it's overwhelming to keep track of such a high volume. Rather than looking at, like when you click on jobs and it just shows everything you've ever sent, experiment around with the search boxes and drop down the status and change that to like checked in and hit search, and then you're going to see only the devices that are here. You can also sort by date. You can check and see like what devices we're still expecting from you, because I know some of you register for them and don't ever send them. And right now I don't have a system in place for expiring job IDs. They just stay active forever. But that's something that's coming right around the corner too. So let's get back to this phone. The next thing I'm going to do, that's right, I was getting ready to check and see what was said about this phone. Does it say I tried to fix a bunch of stuff first? Oh, all right. So what I'm going to do is look at the original request that came in, which is what I looked at to decide to issue the job number. And in the original request, I don't really know what's wrong with the phone. I took it apart. I bought a screen, put the screen on. It still won't come on. It does show up in iTunes, but the screen does not light up. Sounds like typical no image to me, man. But seriously, with what we just seen under the microscope, you see how we got solder blobs over here and solder paste down in here? That's not good. Okay, here's my predictions. I am going to predict that my camera is about out of storage. I am going to predict that this has something to do with the previous repair attempt on Touch IC failure. Let's see what we're up against. Let's go ahead and take the board out of the phone, folks. A couple of days ago, I went back and I watched some of my own old videos. Old videos. And beyond editing, I don't watch my own videos. It's just something that I don't do. But I did. I went back and I watched a couple of my old videos, skipped through one, watched almost all of the other one, and I realized just how much vlogging I've been doing. Through all this, I look at people that are like talking to a camera. I look at it like, man, how can they do that every day? Like, how could they be so social to want to talk to a camera every day? And the more I do this, the more social that I feel, and the more I enjoy showing the world what I'm doing, and also sharing other parts of my life and not just the repair side of it. And it's like, whoa, wait a minute. Why do I feel like I want to share that? So here I am, 35 years old, and I'm just now understanding what some of this stuff feels like. And I'm also realizing that for the past 70 some odd videos, not only have I been producing repair videos, I've been vlogging, and I didn't even know it. It's like, wait a minute, when did I start? I'm vlogging on YouTube. I'm talking to a camera. I'm talking to HAL 9000, and which is actually a Nikon L something really low-end camera that is all I can afford right now, but it works really well. But here I am vlogging, and I enjoy it. So I know some of you might hate it, but I will probably wind up putting things on this channel that have absolutely no business being on an electronics micro soldering repair channel. But that goes along with the freedom that I'm talking about. You have the freedom to do whatever you want, as long as you realize that you have the freedom to do whatever you want. We're not going to go back into that in this video because I ranted for quite a long time about that in my last video. Alright, let's finish getting the board out of this thing. And continue my repair vlog. That's what this is. This is a repair vlog. They won't all be repair vlogs. I will publish many things, demonstrations, and things that are not. But for the sake of giving people a real-world experience as to what is going on here, this is a repair vlog. If I just did a flashy snap, snap, snaps, a snap, 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 you would not have a clue as to how I arrived at this, and you're going to be trying to implement the same exact solution on a phone that does not even have remotely similar symptoms. So these lengthy, long-winded repair videos, they really, really, really are necessary. Once in a while, I'm nice enough, I'll put an index to tell you where to skip forward to, or I'll just write skip forward 20 minutes. Alright, what I normally do, like second or third on this board, I'm going to be doing first. We're going to pull the CPU shield because that looks like bullshit. Alright, let's let the hot air heat up. I do wonder why this CPU shield looks like that. I mean, that's just awful. 255, 260, come on, we got 270, 275, 280, 285, 280, 290, 290, we got 300, 300, 305, 310, 315, 370, 380, 390. I bet if I edited this right, I could make it seem like that took like a week. Alright, let's get rid of this goofy thing. Alright, let's start heating this dude up. Dun da 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 da. You know when you start to smell it, it gets just that right smell, and poof, there it goes. All right, let's go straight for the microscope and see what kind of hell this prior screen replacement phone is going to put me through. Okay, so here's what I've got to say about that. I feel like what's happened is somebody considered the possibility of this being caused by long screw damage. It looks to me like maybe they started to remove the screw hole but didn't quite make it, so the screw hole never got pulled off. So I have no idea why that solder paste is there, other than there's some solder like right up on the side of the screw hole. Let's see if I can get that for you. Looks like maybe they just tried to remove the screw hole, right? Or maybe tried to unsolder the shield with an iron. I don't know. Alright, let's troubleshoot this phone. Since I've got the board out of it, I'm not going to power it on. We're just going to buzz down the display connector here, and we're going to check a few lines for shorts to ground, because in no power or a no image situation, it's like almost always something shorted to ground. Let's see, this is a 6 Plus. The 6 Plus is really prone to it to be the Chestnut IC as well. So I'm going to go ahead and load up a 6W tool for you here. Wait, we don't want 6W tool. We want a schematic. And we're going to search up J2019. I think it's the same, right? Yeah, our display connector. What? My enter key sticking? Probably because I got solder balls in my keyboard. Okay, so here's J2019. Let's have a look at it. So we're going to check our 1V8 over here, which that's most likely not an issue because if 1V8 was missing, this phone would not be powering on. If we've got so this could be potentially no backlight. I didn't really cover that very thoroughly, but it could also be one of these chestnut lines shorted to ground as well. So the first thing I'm going to do here at the display connector, I'm going to zoom you in a little closer so that you can see down here at the bottom right what I'm checking. Okay, so I'm going to put my black probe on ground, and I'm going to put my red probe on. Oh, that's nasty. Put my red probe on PP1V8 and I get 8,000 ohms. And then I'm going to go ahead and slip over here. We're going to check PN5V7 LCM, this next pin. And we get 40,000 ohms there. We're going to jump right up. We're going to check the next line. We get 300,000 ohms there. That is most likely fine. Let's go ahead and jump up here and check backlight. Anode. You know which on this phone don't we have two anodes? Yes, they're just not on the schematic. Which means that my test for this could be completely flawed because the connector on the screen does not have the same amount of pins as the connector on the board. So let's go ahead and switch over to ZXW tool here and open up an iPhone 6 Plus. And let's get in real good on that connector. So this was touch. This was our 5V7, that was right. Our 1V8 was right. This was a cathode, not an anode. This was anode. I'm not finding anything immediately shorted here. Yeah, I'm not finding anything shorted, and I'm also so far not finding anything open. So I don't think we have any filters open, but the way I just checked it probably would not reveal that very well anyways. So let's just have a glance over the back of the board here and look for anything crazy. Also remembering and keeping in mind the solder paste on the other side of the board. Why was that there? Okay, how underfilled is Chestnut on this one? Okay, so this is an iPhone 6 Plus where our components right along the CPU. Look at how little look at how little underfill they used on this one. Why is that frame rate so crappy? I'll try to move it really slow. See how we've got very little underfill to speak of here on this whole entire thing? There's not any underfill here. And a lot of times on a 6 Plus you get into risk. Winds up being a little bit of a risky situation to replace Chestnut. This one here, it's actually not going to be very bad. So I'm just going to dig in and we're going to replace Chestnut. Here's your please bro solution. iPhone 6 Plus, no image, replace Chestnut. Right now, me replacing Chestnut is going to take less time than checking all the filters and checking all the image chokes and checking all this stuff. This phone here, for the sake of getting it out of here relatively quickly, I'm going to replace Chestnut. Step one. Hopefully there's none of this solder paste under the CPU because I don't know if you can see, but this is a CPU that has very little underfill, which I love. But at the same time, sometimes it's nice knowing that there's nothing got under the under the CPU. So let's go ahead and let's give these little dudes some room. Let's just flake this crap off of here. Let's flake this crap off of here. We don't want any of this stuff popping loose. Ow! And that hot air is warm today. Dun da 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 da. All right, so our little dot here on Chestnut. It's up here facing this way, so I'm going to come up here and I'm going to put just a little, I'm going to scratch this right here a little bit. See that? Yep. Scratch it up. Actually, you didn't see it. I put a little scratch up here in this, whatever it is, to mark where my hole is going to be. Make sure my dot's going to be. Now we're going to start warming this whole thing up. And we're going to remove chest nads from the board. Letting our heat spread. Moving back in. Okay, this one should do it. Here we go. Here we go. Now right off the bat, you see something that looks familiar here, right? Look here. Let's zoom right in on this chestnut, or the sight for chestnut here, and look at the way our pads look. We got this one over here that's a little grungy. These pads are oxidized. So right here we've got pads under chestnut that were oxidized. And if we look and see what those pads are, like let's just switch over here to ZXW tool and look and see what those pads are. Let's scroll over here to chest nads and have a look at U1501. We've got E2 and E3. These are 5.7 volt lines that are power for the display. And then we also had this top right ball, which is a 5.1 volt line. I believe that one is for touch. So at this point I could most likely reball this Chestnut IC and put it back on. So this IC is going to go in my bin of good ICs because I'm pretty confident that this IC is most likely fine. There's a good chance that if I would have just pushed on the board and turned it on, I probably could have got it to light up. Back over to the microscope. I'm going to put some flux on the situation here with my... Oh man, this is nasty. My flux syringe has so much gunk on it, I can't even believe I'm going to show you this. Alright, now I can't get my big bevel tip down in here, so we're going to let the hackos sing the hacko song that let the guards walking around know that the slave children have screwed with their station. And they can get slapped on the hand with a ruler. So I'm going to hold the temperature up here with hot air. And I'm going to try to dilute what is on the board here with solder. Keeping the board temp up because it makes this a lot easier to do with the tip of this iron. I'm actually having to scratch at those pads a little bit. We're going to need a lot more flux. Okay. Don't want to get our board too hot. We don't want to melt anything else. Now let's see if I can use my iron here to pick up some of these beads. There's nothing I hate worse than stray solder balls all over the board. Alright, so our sight for Chestnut there looks pretty good. I'm going to go ahead and grab us a Chestnut IC. I'm not going to clean that up. I'm just going to go ahead and run with it. Okay, our ball's in the right, our marker is in the right spot. Right, let's sit this Chestnut IC back down on here, and then we're going to give this phone a test. Let's try that in focus. Here we go. Just about got this board up to temp slowly. And we should see some stuff start. I see the leaded solder here starting to melt, so we should have this Chestnut IC melting soon after, although it is going to most likely be lead free. Don't like it. Crooked. Add a little more flux. And we're going to come in from the bottom here for this nudge. Actually, we don't need to nudge it. We're going to call that good. Alright, and while everything is still blistering hot, the next thing I'm going to do is alcohol. Clean this off. Well, not blistering hot. I let it cool a little bit because I'm worried about cracking shit with cold alcohol. Okay. Let's drop this back into a housing. And let us see what happens. And we're going to use my screen today. I know my screen gets an image. Well, it did the last time I unhooked it anyway. Yay, we got image, we got backlight, we got battery charging, we got all sorts of neat things now, guys. So I was wrong. This wasn't anything to do with touch. This wasn't anything to do with touch. What if this board's got touch IC failure? Like right now I'm ready to put this back together. Bam, backlight's fixed, we're moving on. But this was an issue with Chestnut and a bendy flexi board. Like, what are the odds of this phone having touch IC failure as well? Like, I'm curious, like, to other board repair shops, if you bring an iPhone 6 Plus for an issue that's topside, do you go ahead and repair and put in the M1 jumper for touch IC failure when doing something not related to touch IC failure? Like, what do you do here? Like, what are the odds of this phone having touch IC failure? We really don't know that. So I'm not going to put that in this video. That is actually going to be the end of this video. This is a typical iPhone 6 Plus that had no image. This one was caused by the Chestnut IC, which on the iPhone 6 Plus a lot of times it is. And I'd be willing to bet that the IC that I pulled off of this phone would be completely fine. It just needed reballed. I don't think you would have gotten away with refloating it and nudging it because the pads were actually oxidized. They could have oxidized just now, but I sort of doubt it. So that is going to be it for this video. I do thank you all for watching. I hope you have successful repairs, and I really hope you have a good day. I will see you next time, everybody. My son took my tripod again. He's horrible about taking my things. Wait a minute, what's that little red spot? Oh, it is red.